Before that, we will discuss different unit system. I think my screen is visible to you, right?
Yes, sir.
Okay.
చెప్పరా
So, can you read first
ఏమని చెప్పను
unit 1 hectometer equal to 10 decometers? Yeah, somebody please mute yourself. Listen carefully. Okay. 1 hectometer, 10 decometers. 1 decameter, 10 meters. So, are you able to see the screen?
We can see, sir.
Yeah. So 1 meter, 10 decimeters. 1 decimeter, 10 centimeters. 1 centimeter, 10 millimeters. Okay. Uh, you need to remember the relations. Okay. What is the relation between hectometer and decameter is 10. Okay. So 10 times decameter is equal to 1 hectometer, like that. Okay. You need to remember these unit system for
Sir,
our, yeah, please.
sir, can you just do the basics today, sir? Because we have to start to the college on some time.
Okay. Which basics you are asking?
This today's topic, sir.
Yeah, same thing. This is unit system is the basic thing. Okay, to
Yes, sir.
connect. Okay, basics only I am discussing. Okay,
Yes, sir. Yes, sir. Thank you, sir.
yeah. So any scale design that includes you need to know the basic unit conversion system like this. Okay, then we will construct how to construct a plane scale, diagonal scale, vernier scale. Okay, we will see. So before that, you need to know the different conversion of units. So in civil engineering, you will face miles per long chains system. Okay, this is we call generally British system. Okay, so you call 1 mile is equal to 8 furlongs, 1 furlong, 10 chains, one chain 22 yards. So these are all length units. Okay, 1 yard 3 feet. Okay, 1 foot 12 inches. So what is 1 inch again? Anybody? What is 1 inch is equal to in terms of centimeter? No idea?
1.2.
2.5.
Yeah, 2.54 centimeters. So these are the different unit system we are having. Uh, with help of this system, we can able to construct some important engineering scales. Okay. So before getting into construction, we will discuss one important term, RF, capital RF. What is RF means? Representative fraction. Representative fraction is equal to drawing size by actual size of the object. Okay, drawing size by actual size of the object. So I will ask you, uh, is it possible to draw 1 kilometer line? Length of that line is one kilometer. Can you draw 1 kilometer line on the
No,
drawing?
sir. No,
It is,
sir.
yeah,
No,
it is
sir.
not possible. Okay, but how to draw, how to represent that 1 kilometer line on the drawing sheet? There must be some method, right? Some reduction method. Okay, that we call is that we convert that larger length into convenient length, which can be drawn on the drawing sheet. Okay, that factor we call it as representative fraction. Okay, so uh, once again, this actual size of the object, what I am written in the denominator, that is known as uh, that actual object size, that is 1 kilometer, as I have given some example, right? So actual size of the object is in this case 1 kilometer. Now, uh, what is the drawing size that to be drawn on the drawing sheet? Okay, so conveniently I will take 1 kilometer is equal to some 10 centimeter. Can I take 10 centimeter to represent on the drawing sheet? Because 10 centimeter you can easily draw, right, with help of mini drafter, right? 10 centimeter, I can assume, or 20, 15, suitable size. Yes or no? Now, what is representative fraction now? Drawing size by actual size. Now, do you understood what is this RF? Why we have taken this RF? This RF, basically we are reducing with the help of this RF factor, that is this ratio. What we are doing is we are reducing the size of the object. We are drawing, instead of 1 kilometer, we are drawing 10 centimeter line on the drawing sheet. Okay, that doesn't mean there is no 1 kilometer line. Okay, 1 kilometer line is there. Okay, but we are representing on the drawing sheet with the 10 centimeter line. But while writing dimension, we will write kilometer only. Okay, don't write 10 centimeter like that. So this is the representative fraction. Okay, is it clear?
Yes, sir.
Now, if this is the length problem, RF is equal to same, drawing size by actual size of the object. If the problem is area, if the problem is area problem, so what are the units for area? Some meter square, centimeter square,
Centimeter square.
meter square, kilometer square, something like that, right? So, and at the time, the representative fraction RF formula, you need to use square root of drawing size by actual size, square root. Okay, under square root, you need to take the formula drawing size by actual size. Okay, for example, if the problem is in terms of volume, okay, for example, there is a big water tank, okay, having 1 lakh liters of water inside it. Okay, so such a huge volumes. Okay, we need to represent on the drawing sheet. Okay, again, at the time, RF, you can take cubic root of the drawing size by actual size. The drawing size by actual size is same everywhere, but if it is a length problem, you need not take any square root. Okay, if it is area problem, you need to take square root. If it is a volume problem, you need to take cubic root of drawing size by actual size. Okay, after converting same uniform units, okay, then you will find the representative fraction. That means we are decreasing or reducing the actual size of the object for representing on the drawing sheet conveniently. Okay, is it clear the concept behind why RF we have taken? So let us discuss some applications. Okay, can you guess any application where we reduce the size to represent something on the drawing paper or A4 sheet or A3 sheet? Okay, do you find any applications outside?
While drawing any blueprints of buildings or something.
Very good. Large buildings and even map,
Automobile.
automobiles, maps also. It's
Yes,
very
sir. Yes, sir.
Telangana map, so some world map, India map. Okay, actually there are from Kashmir to Kanyakumari, right? A lot of distance, right? Huge distance, but we are representing on A4 sheet, right? So there, if you observe that A4 sheet, okay, you will find scale factor. It is written something like 1 centimeter is equal to some 40 kilometer or 50 kilometer, like that. Okay, so that is actually speaking the RF factor. So with help of that RF factor, that particular map is designed. Okay, I think you can now understood, right, the concept behind RF. Okay, representative fraction, why we are using, where we are using, right, how to calculate RF, right? This is simple formula. Can I move forward? Is it clear till now?
Yes, sir.
Yeah, now let us discuss one more important terms while explaining one problem. I will discuss all the important terms in the construction of scales. Okay, now let us discuss plane scale, problem number 1. Problem number 1. Are you able to see the screen? construction of scale of 1:4 to show centimeters and long enough to measure up to 5 decimeter. Are you able to see the problem?
Yes, sir.
Okay, so construct a scale of 1:4 to show centimeters and long enough to measure up to 5 decimeters. Okay, you will find so many terms here. Scale of 1:4. What is this meaning of 1:4? Anybody can guess?
Ratio.
What is this 1:4? Representative fraction. What I discussed now. Okay, that is drawing size by actual size.
RF.
RF directly has given. Okay, whenever you read the problem, sometimes RF is given, sometimes may not be given. You need to calculate. Okay, in the next problem we will calculate it. In this problem, let us see some other terms involved in the construction. Okay, now so RF is given directly. Now what is the relation between main unit and its sub unit? Okay, what is the relation between different unit system here in the problem? But if you see this problem, it is relating only decimeter and centimeters, right? So decimeters and centimeter. So you need to understand the relation between centimeter and decimeter. So 1 decimeter equal to how many centimeters? 10.
10, sir.
Very good. That I already shown you, right? One chart. Okay. 10 centimeters. 1 decimeter, 10 centimeters. Now, see what we are going to do is we are constructing a scale. We are designing a scale. With the help of that scale, we can able to measure up to 5 decimeters. Okay, you can measure 4 decimeter, 7 centimeter, or 3 decimeter, 7 centimeter, like that. Any value within the range of 5 decimeter you can measure. Okay. So now tell me, have you seen any ordinary scales like 15 centimeter scale, 30 centimeter scale, right?
Yes, sir.
Even if you go to shops, there is a cloth showrooms. Okay, there you will find 1 meter scales also, right? Maybe steel or plastic, right? Now, see here also we are doing the same. See here also we are doing the same. We are constructing a scale that must be capable of measuring 5 decimeters, and you can also measure with the help of the same scale even the next unit. Main unit is the decimeter and the next consecutive unit is centimeters. Okay, so with the help of this scale you can able to measure any value within the range of 5 decimeters. Okay, is it clear? Now coming to the design part, now tell me what is the shape of ordinary scale you are looking at your place? Rectangle, right? So very good. So in this construction, first of all, let us construct the rectangular scale. Okay, rectangle shape. Okay, now what are the dimensions required? Suppose you are the customer, right? I am the shop owner. You will come to me and ask, I need some 15 centimeter scale, right? Similarly, here also, the problem itself is saying that I need 5 decimeter scale. So tell me what is the total length of that scale? 5 deci. 5 deci.
50 centimeters.
Yeah, you
No, 50
say,
centimeters.
yeah, the 50 centimeter or 5 decimeters. Okay. Now, what is the width of the scale? Generally, you will find at your home, right? What is the width of that scale? Is there any importance given to that? Only length is important for us, right?
Yes, sir. No,
So,
no importance is given to that.
yeah, width you can take any value. In our construction, generally we take 20 mm or 30 mm. Okay. Now, before that, one important calculation we have to do. So, if you see this problem, RF is given directly. Okay, you need not do anything. That means drawing size is 4 times less than the actual size. That is the meaning. Okay, drawing size numerator is 4 times less than the actual size. Here it is denominator 4. Okay, so that is called reduced scale. So we are doing some reduction, 4 times reduction. Okay, since we are not able to accommodate the total 50 centimeter on the drawing sheet, so we are using reduced scale of 1:4. So to accommodate that 5 decimeters. Okay, now RF is given directly in the problem 1:4. The next data given in the problem is what is the maximum length with help of the scale, what is the maximum length we can measure, or long enough to measure up to 5 decimeter is given in the problem. So that is the maximum length. That is the customer requirement. What I said, customer requirement. Maximum length is equal to 5 decimeter. That is given in the problem. You need not do anything with the maximum length ml. Now, this is the important calculation, length of the scale. We are designing a new scale. With the help of that scale, we are able to measure up to 5 decimeters, and we can relate decimeters and centimeters, right? It's a new scale we are designing, right? For that new scale, what is the total length? How to get the total length? We are reducing 4 times, right? So we need to multiply that representative fraction with the maximum length given in the maximum length to be measured, which is given in the problem itself. Okay, now calculate representative fraction. 1:4 is given, maximum length is given 5 decimeter. Now this 5 decimeter we need to convert into centimeters, because our mini drafter contains only centimeters and millimeters, right? So you please convert decimeter also into centimeters. Multiply with 10. So you would get how much value?
12.5.
50. Total 12.5, sir.
12.5. Yes. Now take your mini drafter, draw 12.5 centimeter line on the drawing sheet. Okay, divide this into n number of equal parts. So how many number of equal parts we need to divide? See here, with help of that scale, we need to measure 5 decimeters, right? That is the maximum length is 5 decimeters. Okay, now how many parts if you do this 12.5 centimeter, so that it is convenient for us? Any idea? Can you guess?
Should we cut it into 5 parts, sir?
Yes, very good. Why?
5 parts.
Because if you divide 5 parts, each part will be how much?
1.
12
One.
parts.
No, 1 decimeter. So
1 decimeter.
10
here
centimeter.
12.5 centimeter, you forget it. What you need to think behind that 12.5 centimeter, there are 5 decimeters actually. Okay, actually this 12.5 centimeter line represents actual distance of 5 decimeters. Okay, because we have done reduction, it is only 12.5. Otherwise, what is the total length of that scale? 5 decimeter only, right? 5 decimeter means 50 centimeter. 50 centimeter by 4, how much? 12.5. That means
12.5.
what we have done, we have reduced the actual length of the scale 4 times. 4 times. Okay, that's why it become 12.5 only. But don't keep 12.5 in your minds. In your minds, you need to remember always this distance, this length, whatever we have calculated, even though it is 12.5, in your mind, you need to assume this particular length represents total distance of 5 decimeters. Understood? Total distance of 5 decimeter. So if I divide this 5 decimeter into 5 equal parts, then each part will be 1 decimeter.
1 decimeter.
Understood?
Sir. Yes,
Okay,
sir.
so that is the reason why we need to take only 5 equal parts. If you go by 6 parts or seven equal divisions, there will be a lot of confusion. Okay, it is very difficult to use that scale. Okay, so better you divide 5 equal parts only. Okay, then how to do that 5 equal parts? You know, right? You take a line of any angle, any length, right? Take your compass, draw 5 equal arcs. You know what is the next step? Join the last arc to other end of that line. Okay, with help of a mini drafter or ordinary scale. And now match one of the mini drafter scales to this particular line and tight the mini drafter knob. Draw parallel lines from every arc. Okay, like this. Now, are you familiar with the mini drafter now?
Yes, sir.
Still,
Yes, sir.
yeah. Now, so I have divided. Thereafter, you said already, right? Any scale, it is something like rectangular in shape. Okay. So length is anyway 12.5, but what is the height? You can take any value. There is no importance. You can take any 2 centimeter or 3 centimeter height. Okay. Now, the next step is draw perpendiculars from, we have already divided 5 equal parts, right? Like this. Now we have done partial construction of the engineering scale, plane scale. Okay. Now numbering system. Whenever you draw something, you put a numbering system for convenience. For example, here intentionally I kept this first part. I have not given any numbering. Okay. I have started at the end of the first part 0, 1, 2, 3, 4. I will tell you why we have not started 0 from here. Okay. I will explain. Okay. Now understand there are 5 decimeters on the scale, right? 1, 2, 3, 4, 5. Each part is 1 decimeter as we have already discussed, right? To the right hand side of 0 mark, how many decimeters are there?
4.
4. To the left hand side of 0 mark, how many decimeters are there?
1.
1.
1. Total 5. Now we need to further divide this left hand side part, left hand side of 0. Okay. Again, one more time, we need to divide. On what basis we need to divide into equal number of parts depends on the main unit and its subunit relation. Okay, as we have already discussed, 1 decimeter equal to how many centimeters?
10.
10, sir.
10.
10.
Yes, basing upon that, you need to divide this first part also 10 equal divisions. Okay, how to divide again? How to divide? By drawing one angular line. Okay, like this. Okay, how many arcs I need to cut? 10 arcs because
10.
1 decimeter equal to 10 centimeters. So, and last arc you need to join to the 0 line and draw parallel lines with the help of mini drafter parallel to this first line. Okay, and even you can draw perpendiculars on the first part. Okay, so like that you can draw perpendiculars. That means,
Can you explain again, sir? Which
yeah,
part?
yeah. First part, what we are doing is because 1 decimeter equal 10 centimeters. So I have taken angular line, 10 equal arcs I have drawn. So I have divided. Okay.
But
So
it
I
can
have,
be of any angle, so that angular line.
yes, what we have discussed in the previous classes that
Yes, sir.
angular line can be any angle. Okay.
Yes, sir. Yes, sir.
Here also any angle. Here also any angle. Okay.
Yes, sir. Yes, sir.
Now, from after getting these parallel lines, from each point, you can draw vertical lines. You can draw fully or you can draw half of that box. Okay. anyway, it is only to represent 1 centimeter, 2 centimeter, 3, 4, 5. Now here you see the numbering system from 0 to left hand side. That means from right to left it goes. Okay. So 0 here, 1 centimeter, 2, 3, 4, and this is 5. Here it is mentioned 5. Okay. And 6, 7, 8, 9, 10. 10 decimeter means 10 centimeter means one complete decimeter, right? Now, so in this way you need to subdivide the first part also into 10 equal divisions. Okay, each division represents 1 centimeter. 1 centimeter. Am I clear?
Yes,
So why
sir.
should we work from right to left, sir?
Yeah, since you see, whenever you measure the distance, for example, if I ask you what is the distance, that is the distance between 3 and 5. Okay, that means 3 decimeter, right hand side of 0 mark, 3 decimeter, 5 centimeter, I can say. Okay, since you see the distance is increasing from 0 to left hand side. Okay, you can observe even 0 is here, right hand side the distance is increasing. Okay, 4 decimeter is the maximum distance, you can see. Similarly, from 0, if you go left hand side, the distance is increasing. Okay, yes or no? It's a simple question, right? Yeah, from 0 the distance is increasing. That's why you have to number 1, 2, 3, 4, 5, 6 and all. Okay, that means
Okay,
you
understood, sir. Understood.
understood, right? So from 0 to,
Yes,
if you go
yes,
to 9th centimeter and lastly 10 centimeter means it is composed of 10 centimeter, that is 1 decimeter. Okay, now here also suppose in the problem he will ask you in the exams, you will be given a question like this: mark a distance of 3 decimeter 7 centimeter on the scale. How to mark the distance? What he will ask you: 3 centimeter 7 centimeter, 3 decimeter 7 centimeter. How to mark? First you take your mini drafter. Okay, draw one vertical line at 3, that represents 3 decimeter. Okay, so here you understand one more important thing: why we have subdivided only first part into 10 equal parts. Why we have not done any parts to the right hand side of 0 mark? Because we are not interested. These are the main unit: decimeter, 1 decimeter, 2 decimeter, 3 decimeter, 4 decimeter. We are not interested to subdivide this. Okay, because this particular scale is meant for measuring the relation between main unit and its subunit only. So to measure or to rate the main unit with subunit, we are dividing one more time the first part only. Okay, so whatever the value given in the problem, you can easily use. You can easily mark on this scale. Can you mark 3 decimeter 7 centimeter on this particular scale? You can easily mark.
yes, sir.
You can draw one vertical line from 3 and you highlight 7th line, 7th division. Okay, somewhere here you draw one more vertical line here and you draw one horizontal line what at 1 centimeter away from the rectangular box. You draw one horizontal line that represents the dimension line, and on it you write 3 decimeter 7 centimeter. Okay, that is the way you need to mark a distance, any distance within the 5 decimeter range. Within the 5 decimeter range. Okay, can you mark 1 decimeter 2 centimeter? One decimeter.
Yes, sir.
Can't we do it by directly drawing an arc, like a inclined line, then dividing it into 10 parts?
Which one here in between?
Yeah, 3
No.
decimeter 7 centimeter.
Yeah, understood. Here you generally so as far as plane scale, okay, if you take your ordinary scale, as you said, it is correct. You can directly take 3, okay. If 3 decimeter and 7 centimeter is given, if you divide in between 3 and 4, if you divide it, you will get, okay. Okay, but suppose if I require in between 1 and 2, again I need to divide this part. If I require in between 0 and 1, again I need to divide this one. Instead of doing that, what we are doing in plane scale, to the right hand side of 0 mark, we keep only main unit, 1 decimeter, 2 decimeter, only main unit. You don't find any subdivisions, okay. Only left hand side, only one single part, we are doing the required number of equal parts, so that is sufficient for me to mark any value. Understood?
Yes, sir. So once can you explain like how to mark 3, 7 and all?
3, how to mark?
3, 7. Yeah, you explained, no, sir. We have to draw some horizontal line with 1 centimeter height.
Yeah, from the beginning, right? You are asking.
No, sir. No. From 3, you told us to draw 3, 7, no, sir.
3 decimeter, 7 centimeter.
Yeah. 1 minute. Yeah, okay, understood. So see here, to the right hand side of 0 mark, we are having main unit decimeters, right? So easy here, okay. Just you draw one vertical line here with help of mini drafter, okay. How to show any dimension? We need to draw first 2 vertical lines. In between vertical lines, we need to draw one horizontal line. That is the way to represent the dimension, right? In the beginning classes, we have seen how to put a dimension lines, okay. Similarly here, if you are asked to mark a distance of 3 decimeter and 7 centimeter, you need to draw one vertical line at 3, and at 7th centimeter, you draw one vertical line, okay. Are you able to follow here? This is 1
Yes, sir.
centimeter, 2
Yes, sir.
centimeter, 3, 4, 5 centimeter, 6 is there, and 7th centimeter is there. You highlight that line, vertical line you draw. In between these two extension lines, you draw one horizontal line, keeping a distance of 1 centimeter from the basic rectangle, okay. Don't disturb this rectangle, okay. This is the constructed designed scale. Away from that scale, you take 1 centimeter gap, you draw one horizontal line in between these two extension lines, okay. On it, you simply write with your free hand 3 decimeter, 7 centimeter. So in this way, you can answer any problem. Understood?
Thank you. Yes, sir. Thank you.
Yeah. In this way, you can answer any problem, okay. So like that, okay. Now let us move on to some other problem where some data is not given. At that time, how to solve the problem, okay. Now we will go to next problem in plane scales. Can you see that scale problem on the screen?
Yes, sir.
Yeah, so here again, problem 2. Construct a scale of 1 foot equal to 1.5 inch. In drawing to read yards, feet, and long enough to measure up to 4 feet. Okay, long enough to measure up to 4 feet. So one problem is given like this. Now immediately what you have to see is what is the relation given in the problem? Foot and inches, right? Foot and inches. And what is the maximum length given in the problem? The scale is useful to measure up to 4 feet only. If you want to measure 5 feet or 6 feet with that scale, it is not possible, okay? Because we are designing a scale, okay, for measuring the scale up to 4 feet only, okay? So this is a specific problem. That means you can measure with this particular scale 4 feet only. Suppose you bought 15 centimeter scale in the shop, right? Can you measure with that scale 30 centimeter length? Is it possible?
No, sir.
No.
No, sir.
Similarly, it is this is also the same case. The maximum length given in the problem means you need to use the same length. Within that range only you can measure any value. So maximum length in the problem is 8. Now the relation between the main unit and subunit is foot and inch. Okay. Now I will ask you, what is the RF in this problem? Can you calculate? No? Yes or no? I have given you formula. Okay. Can you apply that formula? Say yes or no. So all are sleeping?
Yes, sir.
Yeah, tell me what is RF? How to calculate that RF? What is the formula?
1/4 into. No, wait. 1 second, sir. Sir, give me 1 minute, sir. I'll calculate and tell you, sir. 1 minute.
What is the formula? Tell me first. What is the drawing? What is the drawing size by actual size, right?
Actual size, yes, sir.
Now read that problem. 1 foot equal to 1.5 inch. Which one is the actual size? Which one is the drawing size? Can you guess?
Actual is foot, sir.
Very good. Actual is foot.
Drawing is inch.
Yes,
Drawing
sir.
is
Drawing is inch.
1.5 inch.
1.5
About
inch.
1.5 inch.
That means outside there is 1 foot, but 1 foot if I am unable to represent on the drawing sheet, so I am conveniently I am taking 1 foot equal to 1.5 inch. I have
Sir,
reduced
1/8, sir.
1 foot. Actually, it is the, like I previously I said, 1 kilometer. Can you mark on the drawing sheet? No, you said, right? Similarly, 1 foot is the given 1 foot. Okay. So he has given that 1 foot also I am unable to accommodate. So I will convert into 1.5 inch. Okay. So actually speaking, 1 foot equal to how many inches? 1 foot.
12, sir.
12 inches. Okay. So I am assuming that 12 inches is equal to only 1.5 inch. That means again some reduction is there. That is the meaning of 1 foot equal to 1.5 inch. So as per our formula, representative fraction, so what is the drawing size and what is the actual size?
Drawing size is
Drawing is
1.5.
1.5 inch. Actual is 1 foot.
Actually is 1 foot.
Very good. So you can write that relation and you can
1.5 by 1 foot, right, sir?
yes, 1.5 by
1/8 will get, sir.
So you can simplify it, okay, by converting into same units. That is important. While calculating RF, you need not simplify this ratio, but you need to simplify the unit system. Inches and foot, you need to convert into same unit, okay? Because RF is a dimensionless, okay? It's a ratio, dimensionless ratio, okay? 3 by 24. Or you can say 1.5 by 12. Okay, this inches get cancels. Okay, keep it as 3 by 24 or 1 by 8. Okay, you need not convert it further. Okay, don't simplify further, not required. Now in this way you need to calculate any RF. Suppose it's a area problem, simply you take the square root of this entire value. If it's a volume problem, how to guess it's a volume problem or it's a area problem? Just read the units. Suppose inch square, foot square is something like that. It comes under area problem or volume problem?
Area, sir.
Area.
Area,
At
sir.
at the time, same formula. Only thing is you need to take square root. Okay. Initially, you need to take the square root. Again, you need to keep all the units in a single unit system and do the simplification. Okay. And rest of the procedure is same. Construction of the plane scale, step by step, everything is same. Understood? Suppose if it's a volume problem, how to identify it's a volume problem? The problem contains units like foot cube, inch cube, okay, or centimeter cube, meter cube, or kilometer cube, something like that. If you find units like that, you need to understand the problem belongs to volume problem. At that time, RF formula is a you need to take cubic root of length on the drawing by actual length. Everything is same. Cubic root will come into picture, and the rest of the length of the scale calculation, construction steps, all are same. Okay. Now I am going for next step is what? What is the next calculation?
Total length of
Length of scale.
Length of the scale. Okay. How
So
to
1 by
calculate
8 into 4.
length of the scale is what
1
is the
by
formula?
8 into 4.
4.
Yeah. So before that, you need to identify what is the maximum length. That is, you require 15 centimeter scale or 30 centimeter scale or 1 meter scale. That is your requirement, right? So the problem says he requires only 4 feet. So maximum length is equal to 4 feet. Then length of the scale, that is, we are constructing a new scale with RF factor of 1:8. So I am unable to take directly 4 feet on my drawing sheet. That's why I am taking a scale factor of 1:8. So again, I am getting a new length. Okay. You need to take once again. I'm showing you how to note down the data. So first calculate, see the relation given and calculate the length of RF factor. Maximum length you note down, and length of the scale in centimeters you need to calculate RF multiplied by maximum length. So again in the maximum length 4 feet, again convert this feet into centimeters only, because your draft are having only centimeters, okay, and millimeters. Can you convert into centimeter? 1 foot, how much? In how many centimeters? Yeah, are you there? I am unable to see you.
Yes, sir.
Yeah, tell me.
So 25 centimeters, sir.
1 foot. First you convert into 1 foot. How many inches?
1 foot
12
is
inches, so it
12
will be
inches, sir.
1 foot 12 inches.
Inches.
So 1 inch 2.54 centimeter. So
yes, sir.
multiply with 12 and multiply with again 2.54. Okay.
15.2 centimeters, sir.
Yes, 15.2 approximately. You will get take that length and you start the procedure. Okay. Start
Yes,
with.
sir.
So you take you would get 15.2 something. Okay, centimeter, and that represents how many feet in actual practice, in actual problem. That represent this line represents how many feet?
almost 1 feet, like more than 1.
No,
1 foot, sir.
no.
4 feet.
Yeah, that is correct. You are not understanding the basic concept here. So what I am asking is, you are calculated 15.2 centimeter, right? So this 15.2 centimeter represents 4 feet in real time. In the real time, that represents 4 feet. Okay, 4 feet I am unable to accommodate on the drawing sheet. So what happened is, I have taken representative fraction according to the given relation in the problem. I have calculated RF factor, multiplied that factor to the maximum length 4 feet. I got this centimeter, 15.2 centimeter. Understood? Actually speaking, 15.2 centimeter represents 4 feet. That is important. You need to understand. Now tell me why I'm asking is, once again, how many number of parts I need to divide this particular length?
4, sir. 4.
4. 4.
Why we are doing 4 parts only?
Because we need
4 feet.
to measure it for 4 feet now, sir.
Yes, sir. We are taking actual scales and not on the drawing sheet.
Correct. Actually, this line, even though it shows only 15.2, forget about 15.2. It actually speaking to us, this line is carrying 4 feet length. Okay, that's why we are dividing this length into 4 equal parts. So that each part will be how much? Each part
1 foot.
1 foot.
1 foot. Very
One
good.
foot, sir.
1 foot. So don't tell me 15.2 by 4 equal some value. Okay, that 15.4 doesn't have any meaning now. Okay, what we are interested is this 15.2 represents 4 feet. Okay, now that's why we are dividing this into 4 equal parts only, which is convenient. Okay, which is convenient. Then easily we can say that each part will be 1 foot. Okay, so let us do. Are you practicing with me or you are doing later? Do you have instruments?
We are listening now and watching the evening video in the evening and drawing it, sir.
Okay, if you, it is better if you practice along with me. Okay,
Okay.
you are having instruments and all. Don't
Okay.
delay, don't postpone. Okay, because I'm almost 1 hour. It's a lot of time I am giving you. Okay, don't waste the time. Practice along with me. That is over now. You need not take some more time, wasting some other time, right? So use the same time. At least practice one problem with me, and that can helpful to you so to make up any other problems. Okay. If you do one problem with me, then that is sufficient to solve any number of problems. Okay. And divide 4 equal arcs, the angular line. Then the last arc you have to join to this end of that line, and you know that you would get so many parallel lines that automatically divides the length into 4 equal parts. So use mini drafter, okay, for drawing parallel lines. Now number system you can follow. Leave first part and start 0 here. 1, 2, 3. 3 feet right hand side, 1 foot left hand side. Okay. So why he is drawing all the horizontal lines means to write RF value and to write feet and inches. Okay. So whenever you write something on the drawing sheet, draw 5 mm lines. Okay. In between 5 mm lines, you insert any data. Okay. So what is the next step? After you need to construct a rectangular box, right? You can take any height, 2 centimeter or 3 centimeter height. You finish one rectangular box and draw perpendiculars. So you would get 4 equal parts, represents 4 feet, total 4 feet. Don't worry about this 6 and 12, I will explain. So what is the height of this rectangle? Any
Any
value.
height, sir, of our choice.
Yeah, any value, 2 or 3 centimeter you can take to show up it as some rectangular scale we are designing. Okay, and more importantly, you need to mark RF value 1:8. You got already calculated. If it is missing on the constructed scale, there is no use of particular scale. Okay, so compulsory you need to mention RF value. And right hand side you write foot, because all main units are foots only, right? Feet. But if you take left hand side, one more part we left intentionally, right? That we are going to subdivide. Okay, so tell me what the relation between foot and inch. 1 foot equal to how many inches?
12.
12 inches.
So
So
we have to divide into 12 parts.
12 parts. Okay, by taking any angular line. Okay, then so many arcs you can take, join last arc to the other end of that line, first part. Okay, 0 line. Draw parallel lines with help of mini drafter, and you can even draw perpendiculars from. So already you got so many parallel lines from the On the horizontal line, you got intersecting points. From that, you need to draw vertical lines. Even half of the box I have drawn. You can also draw entire. You can extend further. Okay, no issue. So to look for good appearance, I have taken only half of that box. Now numbering system again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 inch, last 12th inch. So total it is 1 foot. Okay. Already we are having to the right hand side already 1 foot, 2 feet, 3 feet. Now construction is over. Now you can use the scale to measure any distance within the range of 3 feet or 4 feet. Sorry, you can use the scale for measuring 4 feet. Okay. Now I will ask you where you need to how to mark a distance 2 feet 7 inches.
At
Can
2,
you
we have to draw a horizontal, a vertical line, sir.
vertical line, and at 7th
7.
inch you can draw vertical line. You draw
To join by one horizontal line. Then we have to write
horizontal. Yes,
2
2
feet
feet
7 inch.
7 inch. That's it. Okay. In this way, you can mark any value. Suppose I have given you 0 feet 8 centimeters. Can you 8 inches? Can you mark 0 foot
Yes, sir.
0 foot 8 inches? Can you mark?
Yes, sir.
So at 0 you need to draw vertical line, and at 8th inch you need to draw vertical line. The distance, a small distance, is known to be the required value. Okay, is it clear? So we have applied this plane scale for measuring length. Okay, even if area problem is there, after small calculation modification, right, taking the square root for RF calculation, we can adopt the same procedure for construction of even area problems, okay, volume problems. Yes or no? So can you apply this method to construct any value, any plane scale? Why we are calling this as plane scale means we can see any problem. You can see the relation between one main unit and its subunit only. Okay, only simultaneously you can see only two units. If you want more than 2 units simultaneously, then we need to go for diagonal scale or vernier scale. Anyway, vernier scale is not there in your syllabus. We are having only diagonal scale. We can solve only problems up to diagonal scale. Maybe we will discuss in detail in the next class. You may now ask some important questions if you are having specifically. Okay.